This video I'm going to go through our notes for section 2.1, and this is on writing and solving inequalities. So often when we have equations, we end up with a singular answer, like something like x equals 3. With inequalities, we've got 4 different options, and these are what those 4 different options are. So instead of just the regular equal sign, you're going to see one of these. And we're going to read this from left to right, just like we read our sentences, just like we read normal equations. And as we do that, that's why this specific symbol means less than, for example. Because if we're reading from left to the right, then that means whatever is on the left is less than whatever is on the right. Okay, so this symbol specifically does mean less than. So for example, if I were to write x is less than 3, then that would mean some number x could be any of those values that are smaller than 3. And if I were to write that in words, x is less than 3. Right, so the way that we would say that and we would write that in words, what we're really doing here is we're kind of translating back and forth between the symbols and the words. And we can just kind of go piece by piece. X is less than 3. And so part of what we're going to be doing is kind of figuring out how to translate these words into mathematical inequalities and vice versa. So we've got these 4 different symbols, less than, greater than. If we put the line underneath, that means it could be less than or equal to. Whereas if we have something like this, it can be anything less than 3. So for example, x could be 2.999999. It could be anything right up to 3, but it can't be 3 exactly. Whereas if we say less than or equal to 3, then it will also include that 3. Some things to note, the wording in some of these can be a bit a place of challenge for students. If we talk about the sum of 2 numbers, we're talking about addition. The difference of 2 numbers is subtraction. Product of 2 numbers means we're multiplying them, and the quotient of 2 numbers means that we are dividing them. So in some of our practice problems, you'll see that wording. So for example, you might see the sum of some number x and 3. So if we said the sum of some number x and 3, that means I'm adding them together, is greater than 5. Hey, we could write this equation out. We could translate that from words, and then later on we'll get into the whole solving bit. Also, thinking about words, if we say something is at least as big as something else, that means that it could be equal to it, or it is greater. If we say something is at most another number, then that must mean it is less than or equal to that. Similarly, if I have some number is no more than another number, that means it is not more than another number. It means it has to be less than another number. And then we can switch that around. If something is no less than something else, then it must be not less. It must be greater than or equal to. So this is just some of the wording I know that is in our practices that can be a little bit challenging for students, and we need to get used to. But let's look at the examples that we have here. These ones are a little bit more straightforward. A number w minus 3.5 is less than or equal to negative 2. So again, we're just going to read this left to right, and we're going to translate bit by bit. So a number w minus 3.5, that's just w minus 3.5, is less than or equal to negative 2. So another way that this could be worded would be the difference of a number w and 3.5, right? That would also indicate subtraction. Moving on to the next one, 3 is less than a number n plus 5. So this wording, again, seems like it might be a little bit weird, but if we just go bit by bit, so 3 is less than a number n plus 5. And again, this could be worded as the sum of n and 5, okay? That might be another way that a problem like this could be worded. 0 is greater than or equal to twice a number x plus 1. So 0 is greater than or equal to, and this is another place that students get thrown off a little bit, twice a number x. So how could we write twice a number x? So twice a number means I want that number 2 times. The easiest way to write that is 2x, which means 2 times x plus 1. So if this is something that you find a little bit confusing, go back and read through these and take note of how we're translating these sentences. And then as you're doing practice, make sure to come back and look at these if you run into any of these words and you're struggling to kind of figure out what they mean. Next, we're going to look at determining whether or not a certain number is a solution for an inequality. And we're going to treat this exactly like we did when we had equations. Okay, we saw problems like this in the past where we would ask you, is this number a solution to the equation? And when we want to know if something's a solution, we're going to substitute in for x, and then we're just going to see if that makes our inequality true or not. So for example, in this, if I substitute 4 in for x, or sometimes we say if we plug in -4 for x, we want to see, does this make my inequality true? If it does make it true, then it is a solution. So this would be -4 plus 8 is less than -3. Let's combine our like terms. So -4 plus 8 is just 4, is less than -3. Is that true? No, this is false. So this is not a solution. Okay, let's take a look at the next one. -4.5x, remember that means -4.5 times x. So -4.5 times -4 is greater than -21. So when we do this multiplication, -4.5 times -4, we're going to end up with a positive value. So I know that this is true already. So -4.5 times -4 is positive 18, is greater than -21. This is absolutely true. So yes, this is a solution. One thing you need to be careful of with inequalities and negative numbers is just recognizing that as we're going left, so easiest to think of this as a number line. Remember, as we're going to the left, if this is 0, -1, and I go a couple over, I'm at -4. Say this is 1 and +4. As we go to the left, notice that the number gets bigger, as in like this is a 1 and this is a 4, but that's actually a smaller number. This is something you need to be careful of. Anytime a number is left on the number line, it is smaller than a number that is on the right. Okay? So even though the number 21 itself is bigger, that's -21. That's way over here on the number line. Positive 18 is way over here. 18 is a larger number, right? Positive 18 is a much larger number than -21. Moving on to graphing. Okay, remember, inequalities represent a number of solutions, so it's not just one solution. If it is less than or equal to or greater than or equal to, we're going to use a closed circle that represents that the value is included in the solution. So let me just draw this out here real quick. So y is less than or equal to -3. So if this is my -3 and y is any value less than that, I'm focusing on the values that are over here. This is the way that I would shade this. And then I'm going to put a closed circle at 3. That indicates that -3 is actually a solution as well, okay, because it's less than or equal to -3. Just going to draw both my lines here while I've got the same pen out. Okay, looking at B, so 5/2, 5 halves. We could also write that as 2.5. And that is less than x. So x is all of those values greater than that. So we're going to be shading this way. And since it's greater than but not equal to, that's where we're going to use this open circle. And anything over here would be a solution. Okay? Any value larger than 2.5 would make this inequality true. Remember, that's what we mean when we talk about solutions. Any value for that variable that would make the inequality true. Finally, z is greater than 0. So if this is 0, it's not greater than or equal to, so it's an open circle. And we're shading all of the values over here would make that true. Final example, the graph shows the height restriction h for a ride at an amusement park. Write and interpret an inequality that represents the height restriction. So if you've ever been to an amusement park, there's always certain rides where you have to be a certain height to ride them. And in this case, it looks like you would have to be greater than 48 inches. And since this dot is filled in, you could also be exactly 48 inches. So in order to ride the ride, your height must be greater than or equal to 48 inches. And that's what we would want to write in our interpretation. In order to ride the ride, in order to ride the ride, that sounds weird, but I don't know how else to say it. You would have to be at least 48 inches tall. There we go. Make sure that you get a lot of practice with this, especially these word problems, and come back here if you're struggling to decipher some of that. Hopefully this will help you a little bit there.